Hey everyone. So in this video, I like to talk about domain and range. So, we're going to be using functions and we'll use functions to sort of model the world around us. And, if we want to use these things effectively, we really should be aware of two things, right? The values we can reasonably input into our function, as well as the values that we can reasonably get out of our function. And so here, what I mean by that, I can illustrate in this sort of friendly example. So here I've got a function. So the idea is that, let's say that we've got a 15-gallon gas tank, and the cost to fill up this gas tank is given by the function c of g is equal to 3.9 times g, that input g, right? So c, the output, it's going to give us the cost to fill up g gallons of gas, right? So the input. And so we can plug any number we want into this function. I could plug in 100, I could plug in 50, but these values don't make sense for what the function is trying to do, right? It's trying to give us the cost of filling up a 15-gallon gas tank. And so it really only makes sense to plug in values between 0 and 15 to draw any meaning from this function, right? So although we can plug in any value for g and obtain an output, the tank can only hold up to 15 gallons, right? So it doesn't make any sense to plug in anything more than 15. And then moreover, we're not going to pay money to fill up negative gallons for this tank, right? So we shouldn't input any values below 0. Right? So this is kind of the idea of the notion of domain. Right? So the domain of a function is the set of all reasonable input values for the function. And so the idea that we're going to plug in, or the idea that this is a 15-gallon gas tank, suggests that we really shouldn't be able to plug in values outside of 0 to 15. And so really the domain, the values that we should be, that makes sense to input into this function, are the numbers between 0 and 15. Right, so this is the domain for this function. And we've talked about interval notation, and so we can also write this as bracket 0, comma 15, close brackets. And so this is any number between 0 and 15, we can ask, what does it cost to fill up this much gas into the tank? And so there's an analogous idea, but for outputs of a function, right? So the range is what we call that idea. The range of a function is the set of all reasonable output values for a function. Right, and so in this case, because we know we're only going to plug in values between 0 and 15, we know that our function is just 3.29 times the gallons of gasoline we put into the tank. We know that our range of outputs, the range of prices we'll pay, that we can possibly pay to fill up this tank, fall somewhere between, here maybe I'll write it in the same way. So the range, right, the set of outputs we can get from this function fall between, well, it's going to cost at least $0. But it's not going to cost more than whatever 3.29 times $15 is, right? So this is sort of the most. Oops, let me erase one more. So this is the most we'll pay to fill the tank, right? This is the case where there's no gasoline in the tank to begin with, and we're filling up the full 15 gallons. This is the most we'll pay, right? So our range is going to be somewhere between, or it's going to be any value between, actually, let me rephrase this. We can get a cost anywhere between 0 and 3.29 times 15 as the cost to fill up the tank. And so this is the range, the set of all possible outputs, and in this case, all possible costs to fill up the tank. And so here, so 3.29 times 15, so this is really the same as $49.35. This is the most that can be paid to fill up the tank. And so the range in interval notation, it's values between 0 and 49.35, both in brackets, because we can actually end up paying those costs. If we've got a full tank of gas, we'll pay $0. If we've got an empty tank of gas, we'll pay $49.35. Okay, so here let's take a look at a slightly different example, one where we've got graphs floating around. So here I've got the graph of some function, c of t, and this function, this graph, it's telling me the temperature in degrees Celsius of a city t hours after 2 p.m. Right, so here this is a function, it passes the vertical line test, and it's describing the temperatures in the city, right? The outputs, the vertical coordinates are the temperatures, and it's describing these temperatures t hours after 2 p.m. Right, so here maybe let me ask you to pause the video and try and answer these 3 questions, and maybe when you're ready, we can go through these examples together. But here, begin by trying to figure out, evaluate c of 5, figure out the output when the input is 5 for this function, for this graph. Solve c of t is equal to 4. And then see if you can think of what the meanings are of your results. So I'll give you a moment to work through that. Okay, so here this c of 5, right, this is saying we've got an input of 5, figure out the corresponding output. All right, so we're going to take a look at this input of 5. We're looking at this point here, the point here, it's 5 for the input. And what is it? We've got 7 for the output. Right, so c of 5 is equal to 7. The output when we have an input of 5 is 7. Now this next problem, it says solve c of t is equal to 4. This is saying, okay, the output is equal to 4. What corresponding inputs do we have that give us such an output, give us an output of 4? And so here, I'm going to look at this graph. And here, these are all the points with a y value of 4, right? So here, there's one point here, there's one point here, another point here, and another point here. Right, so here, these are all the points. And so there's one point with an input of 0, where I get an output of 4. There's another point with an input of, what is this? This is 2, with an output of 4. This is a little more than I bargained for, but I think that's okay. This is a point with an input of 4 and an output of 4. And this last point, well, this one's a little bit ambiguous, but I think it might be safe to say it's roughly 7.5. Or maybe we'll just kind of except that that's kind of the best we can say for now. It's roughly 7.5 for an input to give us an output of 4. All right, so here maybe I'll say t is equal to 0, 2, 4, and 7.5 are such inputs that give us an output of 4. And so what do these results mean? So this first result here. So this is saying, right, this input represents the time, the number of hours after 2 p.m. So this is saying, an input of 5 here, it represents the time 7 o'clock. This is saying at 7 p.m. We got an output of 7. We have, it was 7 degrees Celsius in the city. That's what that means. C of 5 is equal to 7 means that 5 hours after 2 p.m., that's what the input means, we had that the city was 7 degrees Celsius. And the output is a temperature reading. Okay, and so what about this? Solve C of t is equal to 4. This is saying we know that the temperature is 4 degrees Celsius. What times in the day was the temperature 4 degrees Celsius in the city? And so we're saying that 0 hours after 2, 2 hours after 2, 4 hours after 2, and 7.5 hours after 2 o'clock, our temperature was 4 degrees Celsius in this city. And so this is really telling us that at 2 p.m., what is this? 2 hours after 4 o'clock, so 4 p.m., 4 hours after 2 o'clock, that's 6 p.m. And then lastly, 7.5 hours after 2 o'clock, that's 9:30 p.m. I don't know why I wrote that, p.m. It was 4 degrees Celsius in the city. Okay, so hopefully that was pretty clear. Maybe let's apply this idea of domain and range. So, we define what domain and range were. So the domain, right, it's a set of all reasonable inputs, the set of all inputs we see in our function. And so what is the domain of this function? Well, here we can see all the hours of the day that we measured data for, that we could input into this function, right? For example, we have an input of 0. That's something we can reasonably input into this function. We have an input of 2, 4, 5, 7.5, and everything in between we see as an input value to this function. Actually, really, all values of t between 0 and 8, we have a temperature reading for and can reasonably plug into this function. Right, we see that if I plug in 7.5 into our function, we get roughly 4, right, out for our function. And so all these values that we can see along our horizontal axis, these are the input values that make sense for this function. These are the values in our domain. So here our domain, it's the set of values between 0 and 8. Right, and what this is saying here is our input represents the time after 2 o'clock, right, the number of hours after 2 o'clock. We're saying that we know the temperature from 0 to 8 hours after 2 o'clock. We have temperature readings for our city between 0 and 8 hours after 2 o'clock. And so here another way of saying this is that we have temperature readings of the city between 0 hours after 2, so between 2 p.m. and 8 hours after 2, that's 10 p.m. Right, that's what our domain is describing. What about the range? The range is the set of output values that we see in our function, all of them. It's essentially saying, what were the temperatures that we saw in this day? And we can see that, our highest temperature reading was 9 degrees Celsius that day. Our lowest temperature reading was at the very end of the day. It was 8 hours into the 8 hours after 2 p.m. And really, we can tell that we have every temperature in between, right? We didn't just jump from a temperature reading of 9 degrees Celsius here at this point to a temperature reading of 0. We went all the way down. We read all of the temperatures between those values of 0 degrees and 9 degrees Celsius. And so we have points in the day where we had temperature readings all between 0 and 9, but we don't have any temperature readings outside of 0 and 9. And so here the range, it's a set of all output values we see in our function. That's 0 to 9, including 0 and including 9, right? 8 hours into the day, 8 hours after 2 p.m., we do have a reading, and here we have a reading of 9 degrees Celsius at 6 hours after 2 p.m. Right? So we do see these temperature values, right? This is really saying the temperature readings actually maybe I can say it slightly differently. The city went through all the temperatures between 0 degrees Celsius and 9 degrees Celsius that day, and no more, right? So nothing outside of this range. Okay, so let's do another example kind of like this, but maybe without all of the scenario floating around, just sort of, just given with a straight graph, a bare bones graph. So let's find the domain and range of this function. And so I'd recommend pausing the video and seeing if you can try this example out yourself. We'll go over it together in a moment. So the domain is a set of all input values for this function. And again, our inputs for our functions, they're typically described by a horizontal axis, right? So we're really asking about the x values in this case, or typically we think of the horizontal axis as corresponding to an x-axis. We're looking at all the input values we see for this function. All the input values sort of lie between this -3 and 5 range, right? And for example, I see a point here with an input value of -1. I see this point here with an input value of -3. I see this point out here with an input value of, here maybe let's do, I see this point here with an input value of 1.5. Really, I see all of these input values between -3 and +5 somewhere on my graph. But this point here at the very end on the right, it's not included, and so we don't actually see a point with the value with the value +5 as an input to this function. And so this domain, the set of all input values that we see here, it consists of the values between -3 and +5, including -3 but excluding +5. Okay, now what about the range? Or we're looking at the output values, how, in some sense, how high this graph goes and how low this graph goes, and does it hit everything in between? And well, how high does this graph go? Well, the highest it gets is this +4, this value +4, and it goes as low as and hits everything in between, this value of -2, right? Every value between -2 and 4, we can see as an output value to this function. For example, if I ask where in my function, right, I'm expecting to see somewhere in my graph an output of +3 because it's sort of contained in this range. Well, where do I see an output value of +3? I can see one right here. I can't tell you exactly where that point is. Maybe it's at an input of -2.4, -2.5. It's hard to say. But I know that I do have a range, or I do have positive 3 in my range, in my output values. And so here, my range, it's a set of output values, and that's from -2 to positive 4, inclusive for both of them, right? Here, I don't see an open point there. It looks to me like that point 3 comma -2 is a point on the graph, so I see a point with a y value of -2. So that's included, and I see a point at the very end with a y value of 4, and we see points with all the y values in between. So this is our range here, from -2 to positive 4. Okay, so let's go ahead and determine the domain and range for some of our list of common functions. So here I've got 3 different functions. This isn't the full list, but these are some nice examples that I want to talk about today. So here, f of x is equal to x squared, so quadratic. I've got a square root function, and I've got a reciprocal function, 1 over x. And so maybe before we talk about the domain and the range of these functions, let's remind ourselves how these functions look. So I'm going to take a moment to make a table and graph these functions, get a rough picture of these functions. But these are examples of functions that you'll want to know pretty well so that you won't have to keep making tables to plot them or to graph them. You'll want to be able to graph these just from memory. So f of x is equal to x squared. So here, maybe I can make a quick table. If I plug in 0 into my function, well, f of x, it squares the function, right? So I get an output of 0. If I plug in 1 into my function, I get, well, squaring that is 1. If I plug in 2, squaring that is 4. 3, squaring that is 9. On the other end of the spectrum, plugging in 1, squaring that gives us positive 1, right? -1 squared is -1 times -1, that's positive 1. Plugging in -2 into the squaring function gives me -2 times -2, that's positive 4. And really, we sort of see the same output values as we see on the positive side of things for these inputs of -1, -2, -3, and so on. Right, so here we get the points 0, 0, 1, 1, 2, 4, 3, 9 is off the grid, and so maybe I won't plot it, but I think we'll get the main part of the graph here with -1, 1, -2, 4, and we can see that the graph would look something like this, right? So here we get this, what's called the parabola shape, this bowl-shaped graph. Okay, and then what about g of x? G of x is a square root function. Right, and so here if I plug in 0, right, the square root of 0 is asking what number squared gives us 0, and that's 0. Right, 1, square root of 1 is just 1. I can plug in 2, and our result is the square root of 2. This isn't a nice number. It's roughly 1.414, so on and so on and so on. But it is a number, it's just not a nice one. I can do the same thing for 3, maybe I won't go there, but the next nice number we could plug in is 4, right? The square root of 4 is 2, and then the next one after that, that'd be 9 that we could really plug in. And of course, again, we can plug in all the numbers in between, but they're just not necessarily friendly numbers, but we do get a value. And so here, plotting these points, we get 0, 0, 1, 1, 2, 1.414, so maybe somewhere like there. 3, 9, I guess here we're already out of space. Oh no, 4, 2 is something I can plot. And so the graph looks something like this. And then I guess I should say that we could try to plug in a negative number, right? So here we could plug in, oh no, okay, here, let me sketch this graph again. Okay, so we could try and plug in a negative number, right, like -4. right? But here, if we do that, and we take the square root of -4, well, this is some imaginary number, and I don't want to go there quite yet. I just want to talk about real values. And so here, this is asking what number squared gives us -4, and any real number I think of, if I square it, it's going to become positive, right? I take a positive number and multiply it to itself, it's positive. A negative number multiplied to itself is still positive. And so here, this is not a real number. And so this is, for the moment, I'm going to call it undefined. I'm going to say this is undefined. And we'll come back to this later on in this course, but for now, let me just say we don't have a result to share for this. Not a real value, not one we can plot on an xy plane. And so we don't see any graph on this left side, any part of the graph on this left side of this coordinate plane, and we actually also don't see anything down below here. Okay, and then one more is this reciprocal function h of x is equal to 1 over x. So here, if we make a table, if I plug in, we've been plugging in 0 first thing, but one thing I want to say is if I plug in 0 into x, we get this fraction 1 over 0. And division by 0 is not, it's also one of those examples of an undefined quantity. And there are many reasons for this, so there are many ways you can justify this. Maybe I will go into this. Okay, so you can think of dividing by a quantity as asking you how many times you would need to add up the second amount to get your first, right? So 15 divided by 3 is 5, since, what is this? This is, since 3 plus 3 plus 3 plus 3 plus 3 gives us 15, right? This 5 is really telling us that we have to add 3 to itself 5 times. But if we try to divide something by 0, right, this is asking us, how many times do I need to add 0 to itself to end up with our result, 15, to end up with 15? Well, this is never going to happen. And so we don't get a result here. This is undefined. Division by 0 is undefined. But actually, anything else we plug in, I could plug in 1 and I get 1 over 1. I could plug in 2 and I get 1/2. 3 I get 1/3. And actually even fractions or negative numbers. Right here, I can plot these points as 1, 1, 2, 1/2, 3, 1/3, 4, 1/4, and we get these really small values. And you can see if I plug in 1/2, well, dividing 1 by 1/2 gives us positive 2. Right, maybe I'll illustrate that here, right? If I plug in 1/2, here we get 1 divided by 1/2. That's the same as 1 divided by 1/2, which is 1 times the reciprocal of 1/2, 1 times 2. Right? And in a similar vein, plugging in 1/3 gives us 1 divided by 1/3, it gives us 3. And we can see that our graph grows really quickly here. If I plug in 1/3, I get 3. 1/4, I get 4. 1/5, I get 5. And the graph looks something like this. Ooh, no, that's no good. On the right side of this coordinate plane, and we see the same thing on the left, but we get negative y values, right? So here this was -1, -1, -2, -1/2, -3, -1/3, and then similarly we also get these sort of skyrocketing values. If I plug in -1/2, I get -2. We get something like this. Okay, and so let's talk about the domain and range for each of these examples. So in all of these examples, the graphs kind of continue onwards out at these sort of arrows. The domain in this first case, right, this graph goes all the way out to the left, all the way out to the right, And the domain is asking us, what, horizontally speaking, do we see all the input values? Does this graph sort of, how should I say this? I think I'm kind of botching my words here. Right, the domain is saying, how far left does this graph go? How far right does this graph go? And really, this parabola goes on forever in either directions. Here, this is all real numbers, negative infinity to positive infinity. The range, though, right, this is a squaring function. It's never going to give us a negative result, and so here we get 0 to infinity. What about this square root function? We saw that we can't plug in a negative number into this function and get a defined result, a defined real number value, and so here the domain is from 0 to infinity. Because we can plug in 0, we're including it, right? The square root of 0 gives us an output. So it's in the domain. The range, it's also from 0 to infinity, inclusive of 0. And then here, this last example for this reciprocal function, it's actually everything but 0. Right? I can't plug in 0 because that leads to division by 0, leads to giving us an undefined result. But everything else is fair game. And then the range, this is actually the same thing. Everything but the value 0, right? We can kind of see here that this graph is going to go all the way up. Right? It's going to continue upwards. It's going to continue downwards on this left side. We get all the y values, above and below. Now the only question is, do we get this y value of 0 here? Does this curve, do these curves ever cross this y value of 0? And no matter how far I look out to the right or to the left, no matter how big x is, 1 over x is never going to be itself 0, right? No matter how big I divide that number 1 by for my choice of x, it's never going to give me 0 out at the end of the day. I can't divide 1 and get 0. And so we're never going to get 0 in our range, but everything else we can get.